This is an introduction to the online daylight tool by Andrew Marsh. In the future, this will likely be called Performative Design tool and hosted under a different website. For now, you will find the tool in the link provided in the description below. This address is likely to change though later on. I'm going to go through a few sections in this presentation, and I'm going to start with the tool itself and what it is about, the interface, the requirements, and then how do you go about calculating daylight metrics. This tool runs on the web page. You don't need anything else apart from a browser. I find that it tends to work best on Firefox, but you're welcome to use it in any other browser. In case you have issues, just change to another browser and try it again. A couple of things before we get started. Regular updates are done on this tool, and if you want to get the latest ones, make sure that you clear the cache of your browser. And in this case on Firefox, you go here to the top right, options, then privacy security. Further halfway down or so should be, yes, cached web content. You can clear this. Make sure that you have deleted the tab with the tool. So I'm going to do it once more. And now I'm going to type in the address, andrewmarsh.com, apps testing daylight room. This is how you get the latest version. Sometimes we might even have daily updates of small little things. Next one, let's talk about the interface itself. The interface is quite interactive. All the commands you would expect from other CAD tools, 3D tools, will be pretty much roughly the same. You've got a range of tools here on the left, top right, bottom left. So these are all the options for visualization or calculations within the tool. If you want to make the tools and the buttons a little bit bigger, depending on which browser you're using, you could just hold down Control on your keyboard and make each one of them bigger. So I'm going to make those a little bit bigger so that you can see on the video. So hopefully that should be fine. Let's go through the interface. What we see here at the top left is sky distribution. That gives us an indication of the sky at a particular point in time. We can choose what type of sky we want, or do it based on a weather data that we have, weather file that we have loaded. And you can load that from here. So we can minimize that. We can make it look even bigger in case we want to focus on this part of the tool. So I'm going to make that smaller and hide it. Then this is the legend where we see the results. Already the tool has calculated the daylight factor for this particular room and shows us a histogram of the results, including the minimum, the average of all of the points on the grid, and the maximum that can be found. Underneath you have snaps for the interface. They're not that important right now, and basic information about the box. Currently this is only allowing you to do a box type geometry. You can change the width, the size, the height, the number of windows, the position of windows, but not more than that. In the future you will be able to do more in terms of geometry. So top left, if you want to edit the windows in any way, add more or remove, if you click on this button, you can insert a window. On your keyboard you could press I, or remove a window by pressing on your keyboard X, or selecting those commands. So if I go into the model, click on a window, if I press X, the letter X takes that away, X takes that away. If I select wall, and press I, insert, we'll put a window there, and so on and so forth. So I can keep on selecting elements and adding windows, removing windows, and so on. So I'm going to take these two windows off, X and X, and continue to the next one. This shows you information about the grid. So if you want to show the grid lines or hide them, if you want to show points, the individual points on the grid or not, can display the values in 3D. Very similar, well, the same functions can be found here at the bottom left. So if I click on those, I get exactly the same results. It's probably a faster way to get to them. Next one is to display shadows in the model. So if I click on sun shadows, this is based on the current location and time that's set for this model. I can find this out by editing the location at the top right. We'll do that in a moment. But if I take off the grid, I will be able to see any sun penetration, as I can see here. Okay, we'll spend more time on this a little bit later. So I can show the ceiling here, so I can display it, or take it off if I want to see through it a little bit more easily. Next one is the design goals. We will use this for a couple of visualization purposes. So we might have a target daylight factor, which we can type the number in here or change it or use the slider. And for visualization purposes, if I bring the grid back on, it already has daylight factors calculated for it. So if I set the daylight factor to whatever it is right now, or let's say make it 6, and then show grid area above the target, it will only show me the area of the room where the daylight factor is either 6 or above 6. If I change that to type 3, then that's 3% or more within that blue area. So I'm going to take that off for now. Continue. This cloud icon is for us to be able to calculate use RADIANCE to calculate daylight factors, or use DIVA to calculate annual daylight metrics. In order to use DIVA, you will need to install DIVA, so you can download it from their website, and you can only use it on a Windows machine. So you would need to have a Windows machine, install DIVA, and then I'll show you later on how you can export from this tool to DIVA to run the annual metrics, and then import them back into the tool to visualize them. So if I continue to the next tool, this is if you want to load a file into the tool or save it. This tool uses a JSON format, so it's .json, and it's a format that you will hear about more and more in the future. So it allows you to save the current configuration, the properties and everything about the model, save it somewhere, and then load it back on. This happens automatically whenever you export to DIVA. A copy of the model is saved together with the calculations. So if you go somewhere else to another computer and so on, you can always reload it back up. You haven't lost your work. Because this is a web page, it doesn't work the same way as with a software where you go File, Save As. It works in a slightly different way. So if we go to the right hand side and to the first one there, we have the information about the model itself. So the room width at the moment is 5 meters, 5,000 millimeters. If I left click somewhere here, I can even see that width. So it does say here with small letters 5,000. So I can go in here, use the slider to make it bigger, and the size adjusts automatically. I can type the number in here. I can just go in there in this dimension, type in 5,000, press enter, and the result is updated. So same kind of thing. Same thing with the room depth, and then with the room height. So I'll leave those as they are. Similarly, for the fabric, if I rotate and bring it here, I'm going to take off the shadows so that we can see a little bit more clearly. If I go to the fabric, the wall thickness currently at 200 millimeters. I can change that and make it to 400, 500 and so on. So for a really old building. So you'll notice that all walls change at the same time. This is what happens with the tool at the moment. In the future, you'll be able to set them separately, each one with its own width. So let's say I keep this to, I'm going to type the number of 250. Ceiling thickness, same kind of thing. If I were to visualize the ceiling, I'll do right now, I can have a thicker ceiling or not, same way as I do with the walls. Reflectance, this is important for daylight calculations. This is a reflectance of wall surfaces. It does all walls at the same time. Currently it's 0.6 or 60% reflectance. I can change it to any number I want or just type it in. So I'm going to go 0.5. Ceiling reflectance, same thing. I'm going to keep it to 0.7. Floor reflectance, again the reflectance of the floor, 0.4. Every time you export to DIVA, which we will do later on, all of these properties are saved as part of the model. Next one are the properties about the windows. Frame, if we focus our attention on the window and we look at the frame, currently the frame width is 50 millimeters. I can change it to whatever I want. That's a bit too much, but you get the idea. I'll keep it to 40. Frame depth, so the depth of the frame, again you can change it, or the color, choose any color you might like. Dividers of the glazing, currently set at 1200, which means that if I click on a window here and I make it bigger, automatically whenever the width is above 1200, that will allow an extra frame to go in, it will put it in automatically, or if it's too small it will take it away, and so on. So these are the dividers, the divider width, and then the divider depth, so that should make sense. Transmittance, the properties of the glass itself, again set it to whatever you want. As you can see, as I'm changing it internally, if you focus here on the grid, the results are updating interactively as I'm changing the transmittance, or generally any property. So I'm gonna leave it at 0.7. Just type it in, 0.7. Okay, next one. We have the daylight settings. The working plane could be anywhere you want. For this example, I'm gonna set it to 750. I can use a high resolution grid, which means that I get many more points. That makes it a little bit slower, not that much on the interface here, not that much smaller, but if you export to RADIANCE and DIVA, it will make it significantly slower because there's many more points to calculate. So I'm going to take that off. The legend, which relates to the legend we see here at the left side of the web page and the tool, we can set the scale of it. Currently it's from 0 to 20% daylight factor. I can change it to anything I want. Let's say from 0 to 5, for example. The colors update automatically depending on what I would like to show. Where would I like to focus in terms of values? I might change that appropriately. So I can change the colors to the contours to 10 of them, or maybe more, and so on. So personally I prefer to go 10 contours. I can change it from histogram to a cumulative graph, depending on what it is that you might want to show. I'm going to keep it to a histogram. And then design, target daylight factor, that's exactly the same as the target daylight factor we find here. Same function, to different locations where you can do it. Next one has to do with the sun path diagram, which relates in this particular case to where the sun is. This will be integrated better into the tool in the future. We can go on to the next tool on the button on the top right hand side. This is the date and time, some useful dates and time throughout the year, summer, winter solstices and so on, and times. But we can set them to whatever we like. What I will do now is take off the grid and then turn on the shadows. And as you can see, we have a model where this is facing north. What I'm going to do is rotate it 180 degrees here, all the way to there. So now this is south. And as I change the date and time, so as I change the time, you can see that the shadows update automatically, either with the slider or with the buttons, smaller time steps, bigger time steps, or also with the dates. So any date and time of the year, you can just put it in and it will update automatically. Location, I can use the location of where I am at the moment. This will require that your browser has access to your to your location. Very often this doesn't happen, so you need to allow access rights to your browser, or you can click on this map and it will bring up loads of locations. It defaults currently to the Isle of Man. You can change that, bring it to London, or you can just type in location, it will find it, apply the changes, and your longitude and latitude have been set based on this. Or you can just type them in if you know what they are, as well as the time zone. Where the north is, currently, there it is, 180. Currently I've offset it for 180 degrees. You can do it manually inside the model as I did just a minute ago, or you can just offset it from here. Next one is information about the model, not much to talk about on this. Snaps, again, not much to talk about there. Next one, surface opacity of the model, whether you'd like to see more into more through the model or not. Sorry, next one. So this is less transparent, so I cannot really see through it apart from the windows. You might prefer this view, or if you want to be able to see inside, set it to somewhere there, wherever you think it's appropriate, or pretty much change it to a wireframe view. That's also a possibility. Again, the outline opacity, how visible are the outlines of the building, the material shininess. This comes through much more when the opacity is set to 1. And then the ambient light in the model. Okay, you can leave those as default, but for some particular screenshots, you might want to set them as you would like. The next one is the 3D views. You have around a number of projections. All of them, this is an axonometric. All of them you can access by clicking different numbers on your keyboard. So, for example, if I press number 2 on my keyboard, so I need to left click inside first. So number 1 is 3D, number 2 axonometric, number 3 is plan view, number 4 side view, number 5 is the other side view. The interesting thing is if I press number 3, so that's plan view, if I press number 3 again, rotates by 90 degrees, press it again, so I can keep on rotating, cycling around the different options of that 3D view. Same thing with the side views. If I press 4 and then 4, I get the 2 sides from that particular view. Again, the 2 sides from the other view. So I'm going to press 1, the number 1 on my keyboard. If you forget which numbers they are, it tells you up here on the top right hand side. Some more information on the visuals. Now let's go back to the grid. So the grid is back on. I'm going to turn off the shadows. If you play with these options, you'll see what they do. They show you the individual values. This is clicking on this number icon. I can zoom in and read the individual values for each one of the points. So 2.35% daylight factor, over here is 6.31, and so on. Much less if I go towards the back of the room. I'm going to turn this off. I can visualize this in a number of different ways. So I can have this smoothly interpolated like it is right now. Colors are blended from cell to cell, or I can have a unique color per cell depending on the value, and obviously the histogram I've set up on the top left. Smoothly interpolated or not. I can show the values in 3D. So this shows me as a 3D graph where each one of the cells lie, and obviously the difference in height signifies the difference in value. I can have it like this, or I can have it like that, smoothly interpolated. Again, these are just visualization techniques. Furthermore, in relation to the grids, I can have the lines being displayed or not, the grid lines. I can have the colors not shown. I can have bands of colors, smoothly interpolated or not. So there's all these different combinations that you can do. That's enough for the introduction to the tool and how it works. So the next section will be the calculation aspect. How do you calculate daylight factors? So in this section on how to calculate daylight factors, you don't really need to do much apart from setting up your model in any way you like. So setting up the window, the position of it, the size of it, and so on. You can click on the numbers, you can do it interactively any way you like. And once you do that, what I'm going to do is take this off. So I'm going to have only one window facing to the south as an example. Anything you do in the model, the results update automatically. You've already seen this, so that should be really easy, super fast. This tool is using the BRE split flags methods, so it's a fairly good method, but it does have some limitations. This is why we only have it as a box. In the future, you will be able to have more shapes, but for now, this is the limitation. So any property you change from the ones we've seen up here, so glazing properties, so the glass transmittance, you see I'm changing the transmittance to a lower value, so it's less light coming through. Obviously the daylight factors drop significantly. As I raise it, the daylight factors increase accordingly. Same thing with the dividers of the window, the frame, and the reflectance of the surfaces. So that's very straightforward. Next part is how do you calculate daylight factors using RADIANCE. So to do this, you have to click on the tool at the top left, the one with the cloud. So you click on it, then remote render service. This has to connect to an online server. In case you don't have an internet connection, you won't be able to do this. So you need to have an internet connection. Sometimes the server might fail. This can happen. What I recommend in this case is that you try again a little bit later. Alternatively, if it doesn't work, then do what we said before. Clear the cache of your browser. Close this tab, clear the cache, and then reload it. There might be an update to the tool. If it still doesn't work, then send us an email, let us know. It should come back very soon. Okay, so the next step, you're here. If the server is online and available, I've already done a run before, so that's why it says this. Otherwise, you wouldn't get this. What you need to do is make sure that the server is online and available, and then click on advanced settings. You don't have to. But these are the settings that will be used in this calculation. These are RADIANCE settings. For those who are familiar with RADIANCE, you will be able to set the parameters the way you want. For the moment, the parameters are set in the way that you see here, and you can see them in the RADIANCE files. You can edit them from here if you want to. So some default parameters could be loaded like this, higher detail, some parameters here. So I'm gonna go for default parameters. I don't want this to be too slow. And then render with RADIANCE. When I click on this button, if everything works, and it should in this case, it will say previous wait, average runtime is currently around 34 seconds. So around half a minute, the tool is running the calculations on the cloud. And we're waiting for the results to come back in. So in the next few seconds, when the results are in, they're already back. So it was quicker than I thought. What we can do is click on View Data. Wait for a few seconds. It's downloading the data from the cloud, from the server, into this tool. What we see here, if we pay attention to the title at the top left, data, it says RADIANCE. So the results are from RADIANCE in this case. We cannot see a lot of difference from before. I'm going to look at this in plan view. And rotate there. And then zoom in also. So here are the values that we get from this. I can click on the cloud again and go to show split flags results. This is the calculation method that this tool is using interactively. If I click on this, I'll get to see the other results, and then I can also show the difference between them. So the difference is in the order close to the window is in the order of less than, on average I would say less than 1% daylight factor. Towards the back of the room it's even less, the difference. So there's not a lot of difference between them, but there is some. I can show the RADIANCE results again. I can show just the tools results, small difference between them. If I go to remote render service again, if I want to save the file that I've just used, this is the JSON file, that's the file format that this tool is using. I can save it somewhere on my computer, or I can save a zip file, which will include the JSON file, as well as all the files that RADIANCE requires in order to run a simulation. So for those who are a bit more advanced with the use of RADIANCE, this might be useful because you can edit those files and do all sorts of different things with them. So I'm going to stop there. That should be enough for a RADIANCE calculation. I recommend, if you're doing an assignment, some kind of sensitivity kind of work, if you want to save your results, save the zip file every time so that you can have a record of your analysis, and then if you ever have to come back to it, you can just load the JSON file and all the results are in there, so you don't lose your work. If I don't save my results, I close the web page and I come back to it a couple of days later, I will have lost my results. So that concludes the online running of RADIANCE and that component of this tool. The next section is how do you calculate annual metrics using DIVA. To do this, you first need to have installed DIVA on your computer. You need a Windows machine, and you need to have downloaded DIVA. If you're a student, that should be for free. You send them your university email and they will send you a license for it. And this tool will connect to DIVA on your computer and will allow you to run calculations there. Make sure that when you install it, that DIVA is installed on the C drive. This is where it's installed by default, so you don't really need to do anything. But in case you have issues and you've selected a different folder, make sure that DIVA is installed on the C drive, so C DIVA, that's all. Alright, so how do you do it? Very similar to RADIANCE. You have set up your model in any way you've decided that it's appropriate, the appropriate parameters, the appropriate settings for the model, and so on. Okay, so the next step is you go again to this cloud icon, generate DIVA DASIM files. DASIM is the tool that actually runs the DIVA calculations. So what you need to do here is, again, make sure that the service is online and available. Currently it is. You need two more steps, so you need to select an EPW weather data file. These are currently located on the C drive DIVA weather data. So if I go to my C drive, DIVA, and then weather data, by default, DIVA will have a range of files in there, and not as many as you can see here on this screen. You can download additional weather data online. I will have in the description a link of where you can go online to download additional EPW, that's the file format, weather data from anywhere in the world, a lot of cities around the world. What you need to do is download them for your location and make sure you place a copy of that file inside this folder, so C DIVA weather data. Once you put it in here, you can select it. So the step here is to click on this green icon, file, so that we select one, and then go to DIVA, weather data, select one of them. I'm just going to randomly choose one. Let's say we go for Vienna, Austria, Vienna. So we selected this one. Then we also need to set up a schedule. A lot of the annual daylight metrics require a schedule of usage. So DIVA will supply you with some sample schedules. You will find them under C DIVA schedules. So click on File, I go to C DIVA and then Schedules. You'll see a range of them. I'm going to go for 8 a.m. to 6 p.m. So 8 to 6 with daylight saving time every 60 minutes. So that it's a CSV file, it's an Excel file. So I'm just going to select that. That's all set up. When we export from this tool to DIVA, all annual metrics are being calculated. That will include daylight autonomy and all sorts of other metrics. For Daylight Autonomy and some other ones, you will need to set up your target level. Very often this is set at 300 lux. You can set it to another level if you so choose. For now, I'm going to leave it as default, 300 lux. And then everything is ready. Click on Generate DIVA Files. This should take only a few seconds. You'll get this dialog box that will ask you to save this zip file. This zip file contains lots of files inside it. It will be stamped with the date and time on it, and date and time of the server, and not of your particular local location. My time here is lunchtime, over there it's nighttime. So I'm gonna click File, Save. In most cases, this is saved under your on your downloads folder. So I'm just going to open that folder. This PC downloads, that's usually where you will find it. Here's the zip file. The other one, you can just close it. There's no need for it. I'm going to go back to here. I need to unzip this. So I'm going to unzip this here. And next step, I'm going to go inside that folder. There's a range of files. The one that you really need to remember is the batch file. So it's a room_diva.bat. This is the executable file that once we click on it, calculations will start to run. So I'm going to double click on this. In some Windows machines, you might get this, your Windows is protected and so on. So don't run, because it gets the impression that this might be a dangerous file. It is not. So you can click on more info and then run anyway. This is the interface of the software running for all those calculations. While this is going on, you can go back to your model, you can check a few things, you can do other stuff. When it is ready, you should be able to tell, because this is going to go away. While we're waiting for this to finish, and the amount of time this takes varies dramatically, the bigger your model or the more dense your grid, the slower the time. So the longer the time, which means that this could take, if you're lucky, anywhere from a couple of minutes all the way to 5 minutes or more. In more advanced settings, this could also take hours. Because we're only doing a box, this should never take that long. In most cases, depending on how old or new your computer is, should be in the region of less than 5 minutes for the majority of cases. For my case, that should be in the region of about 2 minutes or maybe a little bit more. Bear in mind that in more complicated cases with louvers, with shades, with multiple rooms, this will take, and of course more advanced and more accurate settings, this will take much longer. You can set more advanced settings in the HEA file that's located here. If you're a novice user, I don't recommend you edit this, but in any case, you can open this up. It's a text file, and the settings that are used for the calculation are here. For those who are familiar with this or who might become familiar in the future, you can just edit them. You'll be able to do that online, the tool anyway. And this will set up more accurate calculation parameters. For now, you don't need to worry with this. For an assignment or something like this, that should be fine. You can start to see that while this is running, in the folder, a range of additional files are being created. This is DIVA, which uses DASIM and RADIANCE to calculate those parameters, is generating all these files. So it's generating daylight coefficients. You don't need to worry about this. We're waiting for the final results to come in the next few seconds, and I'm going to show you how you can import those results back into the online tool and visualize them. In most cases, this should work. There are some exceptions. If you've installed DIVA into a different folder, it is not going to work. Make sure you uninstall and install DIVA on the C drive only. So C drive DIVA. Even if right now I close this window, so what I will do is I will open up another window, close this one, so it's gone. Then I'm going to go back into this address just to demonstrate and start working on a completely different model. So as you can see, I've got many more windows now. I'm going to change the size of it, so that's completely different to the model I had before. The reason I'm doing this is just to demonstrate that once you've exported to DIVA, the tool saves a copy of the JSON file. You'll see it here somewhere, JSON room.json. This contains all the geometry and all the settings of your calculation. So in the next few seconds, that should be in. So while we're waiting for the results to finish, what I will do is I will have this Windows Explorer there on the side and drag the JSON file, so left click on it and then drag it inside the model. As I do this, you will notice that the previous model with all the geometry, all the settings of it, reflectances and so on, has just loaded. So one good thing whenever you export is that automatically a copy of your model with all relevant settings is saved. So you can always bring it back. This is taking a little longer than I would like in this case. Which means that while this is calculating, you could start setting up other calculations. For example, I might want to see what is the difference between this orientation and then changing the orientation. I'm gonna go in here, change the north by, yeah, that should be fine. It's gonna go there, 145, minus 145. So I've changed the orientation, and what I'll do is generate DIVA DASIM files once again. So I'm going to keep the same weather file, the same schedule, generate the DIVA files, and this will come up with a zip file, save it, click OK, close that. And then if I go back to my downloads folder, you'll notice that I have a second zip, which is this one, and I can extract this one too into a separate folder. That's the newest folder, and I can start running calculations on this in parallel to the previous one. Run anyway. All the results for this one will be generated inside this folder, the results of the other one in the previous folder, so there's no mixing of files. Bear in mind that most new computers are multi-core, so each one of these calculations uses one core. So you could go ahead and use a number of parallel calculations. That should be okay, that should be fine. As you can see from my computer, that's absolutely fine. I can do more than those in parallel. So I have two calculations running in parallel. The other one has progressed a little bit, as we would expect. And let's wait for the results to finish and for them to come back in. The results of one of them are done. So if we go into here, everything is has been calculated already. If I look at the outputs, you will see that if I start from the top, you will, well, if I start from the daylight autonomy, it says room diva autonomy.da. So this is the daylight autonomy calculation. All I need to do is have this file, drag it inside the model, wait for a few seconds, and then the results have been loaded. Bear in mind that I have it loaded on the previous setting, which is with the wrong orientation. So ideally, what I need to do is load up the appropriate JSON file. Now I've got the correct orientation, as you can see there. And now load the daylight autonomy. There it is. Okay, so if I look at this in plan view, rotate it to the way that I want to see it, and then we have at the title daylight autonomy at 300 lux. The one thing to note is that currently, if I look at this in 3D, the model is locked, and if I try to click on something, it doesn't let me, so that I don't play around with the model, because the results have just been brought in and they're relevant only for this configuration. If I want to change it and then re-export, I need to unlock the model and then do my changes and re-export again. So let's look at the results in plan view. I can have all the visuals that I had for daylight factors, same exact techniques, nothing different. If I zoom in, you'll see that the results are displayed in this way. If I rotate that by 90 degrees, the numbers are displayed that way. I can click on the bottom left on the numbers, click on them back on. The numbers rotate to what my current field of view is. So what I'll do now is rotate it back to the direction I would like to have them, and then take the numbers off, put them back on, displayed in the way that I prefer. I'm going to take the numbers off because I'm going to judge things based on color at the moment. So this is showing us daylight autonomy based on 300 lux as a target. If you want to show spatial daylight autonomy, which is more relevant to the space that you're actually dealing with, in this case this one, the way to do it currently, and this is likely to change in the future, is you click on the target icon, you click on 50%, and then show grid area above target. So this is what the spatial daylight autonomy at 300 lux for 50% of the time is for this particular room. The number that you're looking for is the one over here, 29.2. So top left is 29.2 is your spatial daylight autonomy for at least 50% of the year. 50% of the occupied time. So this is how you do daylight autonomy, and then by changing the target to 50% and then only show the area above, you can get the spatial daylight autonomy of 300 lux 50% of the time. I'm going to take those two off and change the scale back to, well, leave the target whatever it is, and then load up another metric. Next one, so we did daylight autonomy and spatial daylight autonomy. The next one will be continuous daylight autonomy. I can drag this roomdiva.cda, drag that inside. Same thing, as you can see, the results all update. This is the scale that we have, these are all the numbers, and so on. So that's spatial daylight autonomy. Next one, we're going to look at UDI, useful daylight illuminances. So there's 3 of them that have been calculated, UDI up to 100, so from 0 to 100 lux. Here's the result. Obviously at the back of the room you've got much higher numbers because that's darker. And then 200 to 2000, kind of middle of the room closer towards the window, and then 2000 or more lux. Obviously you get much more of those closer to the window where you get most of your daylight. For the moment, these are the calculations that you can do with this tool by exporting to DIVA. Much more functionality will be added on a day by day, week by week basis. This is a tool in development, and many more is to come. I hope this was helpful. Any more information will be in the description. There will be a structure to the presentation, so you can click on the relevant section and take you to the appropriate part in the video. Thank you.